goal of this lesson is to model a situation involving half-planes graphically and algebraically. When representing inequalities on a Cartesian plane, we must use two aspects of the inequality, the first being the rule of the line and the second being the inequality sign itself. The first step is to translate a verbal representation to an inequality, then graph the line. The line will be solid or dotted, depending on if the inequality sign is less than or greater than only, which is a dotted line, or if it is less than or equal to, or greater than or equal to, which is a solid line. The half plane will be shaded above the line if the inequality indicates greater than, and below if it indicates less than. There is an exception to this, however, depending on how the equation is written. In function form, this rule holds true always. In general form, it is dependent on the sign of the coefficient in front of the y variable. If it is positive, you will follow the general rule, but if it is negative, you will shade opposite to what the sign indicates. This is because when converting to function form, dividing by a negative results in a change in the inequality sign.
Alright, I'm just going to take a little look at what half-planes are today. And to do that, I'm going to show you, if we were graphing something like y is less than 5. Okay, so I'm just going to pull up the grid here. And there it is. And what do we mean when we say half-planes? Well, this whole grid is a plane, so we're basically going to cut it in half. So what I'm going to do is on the y-axis, I'm going to go up to 5. So 1, 2, 3, 4, 5. So I'm just going to mark that right here. See how the line that's marking it is moving left and right? And that's basically saying I'm looking at a horizontal line through a y value of 5. Now this line is not going to be a solid line because we only have less than. So this is going to be a dotted line. So I'm going to fill this in. There's my horizontal line. And off it goes in the negative direction. Okay, so there's my line. And basically you can say, well, it cuts the plane in half. And that is true. Now I'm going to shade the part of this plane which makes this inequality true. And I'm looking at y values that are less than 5. And what that means is I want to show the ones that are underneath. So I shade this whole region in here. And I have the luxury of time. I can do a real pretty job of that. You get the idea. I'm not going to keep going crazy here. But everything underneath this line is going any point down here. It's going to make this inequality true. So that's what a half plane is. I'm going to just draw a couple more here just to make sure we got the right idea. So the next one I'm going to do is I'm going to graph x greater than or equal to 3. And we're going to pull up the grid again. So this time on the x-axis, I'm going to locate positive 3. 1, 2, 3. And this time the line, it says here, is greater than or equal to. I'm actually going to get a line tool here. Make a better job of it than I can do 3. And there's the line. Okay, so basically there's the line there, heading up and down to the vertical line. And I've got to decide, do I want to shade on the left side of the line or on the right side? Well, I want x's that are greater than or equal to 3. And that means the one on the right side. So here I am shading what are the points that make it true. And there it is. There's my half plane. I'm going to do one more here, and then that's about all we're going to do for half plane. How about x less than negative 2? So, grid. And we want x to be less than negative 2. Well, on the x-axis, I'm going to locate negative 2. There it is. And this time it is a dotted line. And that's because it's strictly less than, not less than, or equal to. Draw the line. And of course, this breaks everything up into the left side and the right side. And which side do I shade? Well, I want to shade the side where the x's are less than negative 2. And that would be on the left side. So there it is. There's my half plane. So that is drop. I'm talking about half plane.
Okay, graphing linear inequalities, part 3. Last time we showed a graph of a particular equation, y equals 2x minus 4, and we graphed it on a Cartesian plane. There's minus 4, and there's a steep cut of line that goes right through it, and we saw that y equals 2x minus 4, that's our line where the two are equal, y and 2x minus 4. Now we saw that if we change that to a greater than sign, then the solution set refers to the entire half plane. A little bit of detail to add in here. Let's look at the 4 similar equations to y equals 2x minus 4. Remember, y equals 2x minus 4 is the line. If I said y is less than or equal to 2x minus 4, what I would do is I draw in the same line, dividing it into 2 half planes, and this says less than or equal to. That means we're looking at the lower half plane, and because it says or equal to, the solution set includes the line itself. So we would do it by shading like this, as we've seen earlier. And here's something a little different. In this case, it's y is less than 2x minus 4, so it would not include the line itself, because the line itself is y equals 2x minus 4. So what we do to represent that is we use a dashed line. And by using a dashed line, the same shading as before, it just shows that the solution set on the graph does not include the line itself, just everything in the half plane that's lower than the line. Same over here, we've got greater than or equal to 2x minus 4, so because it's greater than or equal to, the line, known as 2x equal to 2x minus 4, is part of the solution set, and greater than means the upper half plane. And as you can expect, the same line gets drawn in this case in dashed line, because the solution set doesn't include the line itself. Y is greater than that stuff. It doesn't include what it's equal to. And of course, y is greater than means we have the upper half plane. And those are the 4 ways to graph the 4 possible relations between y and 2x minus 4.